Okay, to continue. Okay, back here we go. So one thing that you want to do is then test those points. It's not just test the points, but you want to find out where that stationary point is. And this one, because you can see that this is a positive, negative, this is going to be indicating that it's a non-stationary point. So let's just take a look at this again, right? So how do we know that it's a non-stationary point, right? The gradient, well, you can only tell if you actually just look at the gradient at that point. Is it positive or negative, right? So you just, if it's a value, any kind of value, as long as, so you do just have to check, is it a non-zero? If it is a non-zero at A, then you know it's a non-stationary. If it is a zero, then you know it's going to be a stationary. So the zero can actually turn up in the first derivative test, as opposed to a non-stationary where it could not turn up in a first derivative test, but it will turn up in the second derivative. So there you have it, because we actually set this equal to 0 because we're testing that. We're testing those critical values. So we are saying that f of x, this idea, f of x is 0. So that is what we want to identify. So this is, as we know it, non-stationary. So non-stat, right? So further, we want C. And C, we can already know what the interval is, where it's increasing and decreasing. So notice that it was decreasing all the way up to 0 and increasing for the rest. Well, that's simple enough. So we can say f of x is decreasing. So f of x decreases, or actually what I'm going to write is the following. I'm going to just say this. I like writing it like this, with a little arrow, decreasing over the following interval, where x is less than or equal to 0. And then f is increasing, where x is greater than or equal to 0. So there you have it. And so that's C. D, we want to find out, what's it asking? Interval where the function is concave up and concave down. Well, just look at the interval here. So it's concave up, right? In the interval between, I would say, x less than 2/3, concave down between 2/3 and 2, and then concave up from x greater than 2. So we can say this. So we're going to say that just by looking at what we have right here, this interval. So this is, I'm going to put it in yellow, that this is all concave up. I'll put pink as concave down. There you go. So we can see clearly where we have concave up and concave down. So you could even do, so concave up, so F, you could even do little concave up smile, and it would be x less than or equal to 2/3, and x greater than or equal to 2. F, concave down, is going to be somewhere between, so 2/3. So we can say 2/3 less than or equal to x less than or equal to 2. Okay? So there's that part. So now all that is left is actually E, and E, sketch the function showing the features that you found. So if we just were to sketch the function, let's just sketch this. So I'm just going to use this. So what do we know? So there's my 0, 0. So we know at, notice what we have. There's a few points that we want to point out. 0 minus 9 is a point. We have, and that's a minimum we know, stationary point at 2, 7. So, okay, so we're going to put those in. So we're going to say right here, this is going to be my 0 minus 9. Right? That's my 0 minus 9. Great. We also know that there's another stationary point at 2, 7. So I'm just going to say Who knows here? 1, 2, 3, 4, 5, 6, 7, let's say. Or actually, it's at 2. So this could be, let's say this is 1, 2, and it's up at 7. So this is going to be 1, 2, 3, 4, 5. Well, there we go. Let's just try this again. There we go. There. So let's just try this again. So this is going to be 1, 2, 3, 4, 5, 6, 7. This could be 1, 2. I mean, this is not ideal, but we know, we can even ballpark it. Instead of making hashtags, this is a sketch. I'm not going for accuracy here. So let's just ballpark it. So we know that this is like 2/3. So it's going to be close to the x-axis. Or, for example, 2. I don't know. 2 is over here, let's say. And then it's going to go up. So here's my point. And I'm going to call that, I'm just going to say, because I'm sketching. Sketches are just, you know, some idea, right? So we know that there's some point. I mean, it's okay. I mean, if you're don't have a calculator, you can, hash marks, fine. You need that. But if it's a sketch, it means it can be a little messy, right? We just want to know what the feature of the graph is. So, okay, so we know though, at about 1/3, 2/3 of the way, and -2, if that's -9, it's got to be -2 somewhere here. Okay, so we know we're decreasing at this point. So, and this is going to be horrible already because I'm doing it on the computer. And it comes back up, and this is already concave. Well, this is already horrible because I'm not doing it on, but it turns over here. So what you see is it's already turning over and then coming up. There we go. So it's doing something like that, right? So it's like whoop, whoop, turning over and like there you go, right? But there's a turnover right here. That's the idea, right? Even that, there you go. Ooh, wow, I can just do the sketch that way. There we go. I sketched it, right? Just to give you an idea, right? That's the whole point of a sketch. So if you're in paper 1, sketch it the best you can. It's as long as you have the points, you try and make it representative of what you know of, and all the information is there, right? So it's here. We know those points. We've tested them. That's okay. And you just try and shift that around. You've already shown where it's concave up and concave down, so you try and emphasize that. There's your concave down. There's your concave up. Then you continue we know that's 2, and then you can just put those in. You know that's 7, right? It's not to scale, but it's a sketch. Sketches aren't meant to be to scale. So just keep that in mind, right? Graph has to be very accurate. Sketch, not to scale. Put in the relevant points. So just here, just make it clear that that is 2, 7. Put it here that this is your 0, -9. Put here that this is that turning point, right? So the non-stationary point. Those are all the indicators that you need. And that's more than enough, right? Because you can see how I was with this sucker hacking away at it, but it's not necessary. When they say sketch, sketch is, by definition, it's a little messy, right? It's not to scale. You're just putting in key features, right? And that'll get you all your points that you need. Okay, and then I'm going to stop it here and then do the next problems.